So now I'll give a brief introduction about the speaker, Dr. C. Shobha Bindu. Dr. C. Shobha Bindu graduated BTech in the stream of Electronics and Communication Engineering from Jawaharlal Nehru Technology University, Hyderabad in the year 1997, and MTech in the Computer Science from JNTU, Hyderabad in 2002, and obtained PhD in Computer Science and Engineering from JNTU, Anandpur in 2010. So in the year 2003, she was selected as Assistant Professor in Computer Science and Engineering at JNTU College of Engineering. She served as an officer in charge of academic section JNTU ACA from 2009 to 2011, and also nominated as officer in charge of entrepreneur development cell from 2012 to 2013. She worked as an head computer science and engineering JNTUA from 2012 to 2015. Currently, she is director for R&D Research and Development Center, JNTU University, Anandpur. She is actively engaged in various professional bodies. She is a life member of ISTE, CSI, IAE, and CSTA. She is fellow of IE and senior member of IEEE. She awarded a gold medal in BTech and stood as university topper in MTech. She received Outstanding Scientist Award for contributions in the field of computer science by Center for Advanced Research and Design. She is a reviewer, editorial board member, and advisory committee member for various journals and conferences. She has filed 3 patents, and she has authored 6 books and also edited 1 international conference proceedings. So thank you, madam. Thank you once again. So welcome for this today's session.
Thank you very much, sir.
Yeah, madam. You can take over the session, madam.
A brief introduction regarding me. And in fact, it is an elaborated introduction regarding me. Thank you very much for that.
Thank you, madam. Thank you.
So, shall I start the session, sir?
Yes, madam. Yes, madam. You can take over. You can start.
Hope it is visible to you all.
Yes, madam. The screen is visible.
Yeah. So the topic for today is web security. So what is this web? Already we all know that a lot of people are making use of the internet, and especially gathering the information from various sources can be done by making use of this web. So according to the latest digital 2019 report from Hootsuite and We Are Social, on an average, it is found that users spend 6 hours and 42 minutes online every day. But because of this pandemic, everything now is going on online. So it is more than the 6 hours 42 minutes that we are spending on an average on this online. So what does people do on when they are being online in the internet? So the people spend most of the time interacting with the web applications, and they may search for a lot of information. So most of the time we are spending on this internet looking for something, maybe for chatting, or maybe the social networking has become so popular nowadays that even a child who is of 6 to 7 years are making use of this social networking sites and all. So most of us are making use of these web applications now. So when you are making use of this web applications, the security of this web has a major impact. So we'll be interacting with these web applications like the web servers, making use of your web browser. So you need to secure your web browser, your web server, and whatever data that is being transmitted between your web browser and the web server has to be secured if at all you want to maintain the data in a confidential manner. So it is like the interaction that goes on between the web server and the web browser. That is what we are going to look at, how this interaction or how this communication between the web browser and the web server the traffic that goes on between these two parties, the web server and the web browser, how are you going to secure this? That is of concern when you go for this web security. So when we look at the basics of web, we all know that we have some web pages that you're going, when you ask for a particular information, the information will be given to us in the form of web pages. So these web pages, they consist of a lot of objects, which when you want to address a particular web page, we'll be addressing by making use of what is known as a URL, Uniform Resource Locator. So based on making use of that URL, you are going to identify a particular web page or a website, and then you can scroll through all the web pages in that particular website. That can be done over there. So most web pages, when we look at, they contain the basic HTML pages. And there may be several referenced objects also that can be present within a particular web page, like the images, something like this you can have in the web pages. So URL, when you see, there are two components that we have in the URL. One is the actual host name and the other one is the path name to reach to that particular host name. So when you want to interact with a particular web server, so this will be done by the user by making use of an application known as the web browser. So the user agent for the web is called as the web browser. So most of the web browsers that we are making use of, most of us will be making use of Chrome, Google Chrome, that is the web browser, or it may be through the Explorer, Internet Explorer, that we can make use of for browsing, or it can be Netscape Navigator that you can go ahead with. So there are a number of web browsers that we can, Mozilla Firefox, etc. So all these are the web browsers we make use of to interact with the World Wide Web. So the server is the web server is the server where all these resources like the web pages are being located. So that web server can be like an Apache web server, which is in a public domain, or it can be something like a Microsoft Internet Information Server. So all these are the servers which hold some sort of information from where you are going to fetch the information. So we need to secure both your, at the user end, you need to secure your web browser, at the server, you need to secure your web server. So how this interaction between the web browser and the web server goes on. So whatever data that is being communicated here between this web browser and the web server will be done by making use of an application layer protocol. So the user can interact with the web server making use of this application layer protocol, which we call it as a HTTP, Hypertext Transfer Protocol. So this is something like as the two parties are communicating, like a web browser and a web server. This is like a client server model that you're going to have, where the client here is the web browser, which makes a request to the web server for getting the web objects or the web pages from the web server. So, and that displays to the end user here. So that is the client that you're going to have in the form of a web browser, and the server is a web server which sends the objects in response to the queries or the requests that are being made by the web client. So HTTP 1.0 is the version that was used previously, and that has been referred to, elaborate discussion on this is being referred to in RFC 1945. And when you go for HTTP, the latest version of HTTP, it is HTTP 1.1 that we have, which is described in RFC 2068. So these are the RFCs which describes the HTTP protocol. So if you are interested in, you can just refer to these RFCs by going into www.ietf.org, where you can find all the RFCs related to the network protocols that we have. So So when we look at the communication that happens between the web browser and the web server, so the pages that you are going to have, the web pages that we are going to have can be of either they can be a static web pages, or they can be dynamic web pages, or there can be some sort of active web pages also. So what do you mean by this as static web pages? So in the static web pages, the static itself, it means that it is unchanged or constant. So whatever web pages that we are going to have at the web server, they'll be constant. They are pre-built, there are pre-built contents that we have in that particular web page, and whenever a browser or the client makes a request for that particular page, every time you make a request, the same content will be delivered to the web browser here. So standard HTML pages are what we call it as a static web pages. So they won't change over the time. So yes.
Can you maximize this PPT? Press F5 on this.
Yeah, it's maximized only, sir.
The PPT is not moving right now. You are currently on which page, madam? Which page? Which slide number?
Slide number 5.
Okay. It was in the first page, in the first slide only. That's
It's in slide number 5, sir.
press the slideshow, madam. There.
I've pressed it, sir.
Madam, press F5,
Now?
madam. Press F5.
F5 I have pressed, sir.
Actually,
Slideshow mode only.
One second. Because we are not able to, the full screen is not visible, madam. Just a part of slide.
Now?
No, madam. Have you shared the whole desktop or only the PPT, madam? The screen.
Just a minute, sir. Now?
Now it's visible, madam. Okay, madam.
Okay, sir.
Okay, continue.
So the static HTML pages are the static web pages that you are going to have, where they remain same. Whenever over a period of time also they remains the same here. So, and the other type of web pages are the dynamic web pages. In the dynamic web pages, as the name itself indicates, dynamic, that is changing or lively over a period of time, they can be changed, and based on the requirements they can change here. So when you go for this sort of dynamic web pages, so when a browser sends a HTTP request for a particular web page which is dynamic in nature, then immediately the web browser, it invokes an application program in response to this particular HTTP request. Maybe that can be some sort of, there can be some sort of transactions that may take place at that particular server, or it may refer to some of the database for fetching the information from the database and then place it onto the web page and then send it to the web server. So the program gets executed and then it produces what is known as the HTML output, and that will be placed into the corresponding fields of the web page and then the web server here. So the content of the dynamic web page will be generated on the fly. So creating these dynamic web pages, they require some sort of server-side scripting also, because at the when a request comes, immediately and then you have to get the corresponding information. So for that we require a server-side scripting also when you go for dynamic web pages, because the content keeps on changing over there based on the request that is being made. The server has to get the corresponding information from the corresponding databases for which it has to run a program and then it has to get the information. So for that it requires some sort of server-side scripting. And the other type of web pages are the active web pages that we have. So these are also dynamic in nature, similar to that of the dynamic web pages, but there's some difference that we have. So these active web pages, they get executed at the browser itself. Rather, the logic behind this will be executed at the browser itself rather than at the server. So the difference here is dynamic. When you refer to the dynamic web pages, they get executed at the server. But whereas when you go for active, they see that the logic will be performed at the browser. So for that, what is required is whenever a request is being made from the web browser to a web server, immediately the web server, along with the basic HTML page, it also sends a small program, some code over there corresponding to this, how it has to perform this particular, how it has to calculate these values or something like this, and then it responds it. So along with the HTML page, a small program also will be embedded and that will be transmitted to the browser. So at the browser will be interpreting these HTML pages and then it will be executing all these small program so that it fills the corresponding pages fields in that particular HTML page. So that will be done by the web browser here. So the client makes a HTTP request. The server will be sending back the HTTP response, which contains the HTML page as well as a program wherein it should be run at the web browser in order to get the corresponding information into all the fields over there. So for this, what is required is you need to have some active programs that has to be run at the browser, like you require some sort of ActiveX controls, the applets that that can be made use of when you go for Java. And nowadays JavaScript like Ajax is being quite popularly being used, wherein this code can be executed at the browser while you are executing while you are getting the active pages here. So these are the various types of web pages that we have. So anyway, the interaction will be between the web browser and the web server. And if it is the confidential data that is being transmitted, that has to be communicated between the web browser and the server, you need to secure the entire traffic here. So how are you going to secure that? So before we go for that security, so we shall look at what are the attacks that are possible with hypertext HTTP protocol. So HTTP protocol, the main disadvantage is the request and the response that you are going to communicate between that is being communicated between the browser and the server are in the plain text format, or it is in the clear text that has been transmitted over the internet when you make use of this HTTP protocol. So those are unencrypted. So any attacker, he can intercept the data. So when he has access to the internet, he can intercept the data and then he can get the contents here. So get the contents of this particular HTTP page here. So HTML pages that are being transmitted between the client and the server. So that the information can go into the hands of an attacker. So that is what we call it as a interception attack, or it is sometimes called as a eavesdropping. So where an attacker can read everything that is being transmitted over the internet. So when you go for this HTTP protocol, so the request will be in the form of get, and then there you'll be getting the get and the post, and then you will be getting the responses here. So when you want to access a particular page, or when you want to access a particular one, so you will be specifying as some sort of parameters to this get and the post. So you can, when you send this information, in this information, along with this get and post, all these parameters can be read by an unauthorized users. For example, when you are accessing a particular website, if you want to authenticate, so you will be giving your username and the password. So that will be transmitted in the form of a get request, get message in the form of a get message or the post message to the server here. So this information can also be accessed by an unauthorized users, or maybe the session cookies that you are going to transmit can also be accessed by an attacker here, so that he can perform any sort of attacks like interception is one thing that can happen, or even in some cases he can perform some sort of active attacks also, wherein he can modify the messages that are being transmitted between the web browser and the web server here. So like for example, like when you are making a request, you can add some tracking information in the request that can be manipulated by an attacker, and then he can transmit it to the other end. Or it can be in the form of in the response also, they can make some modifications, and then modified page can be transmitted to the web browser. So this sort of attacks can be done by an attacker, wherein it modifies the actual information with that of the other information which is intended by the attacker here. So some of the examples, like you can add some JavaScript for sending information to the third party, or you can change the action of a form so that it can be redirected to some of the phishing sites. So all these are some examples wherein you can perform some sort of modification attacks in the during the transmission between the client and the server. So those we can segregate them as passive attacks and the active attacks. So when you go for passive attacks, they do not do any harm to the data. Rather, these attackers, they just intercept the data, look at the data, get the information, and then they can go for some sort of analysis or some sort of attacks like that. So where these passive attacks, they include eavesdropping on the network traffic between the browser and the server, and then they'll be gaining access to the information on a website for which they do not have the access. That is, they are supposed to be restricted. So the other type of threats that we can classify are the active attacks. They include masquerading another user, or impersonating another user, or altering the messages during that are being transmitted between the client and the server, and maybe some sort of modifications that can be done even on the website also. So these are some of the active attacks that can happen. So where exactly these threats happen? So what is the location of these threats? The threats can happen either at the web browser or at the web server, or it can be the network traffic between the web browser and the web server. So the issues of this web server and the browser, like so those comes under the computer security, where you're going to secure your system so that you can avoid unauthorized access to your server, or to the system from where you are accessing these web servers here. So that comes under computer security. So we'll be looking at web traffic security. So between the web browser and the web server, the data that is being transmitted, or communication that is happening between the web browser and the web server, has to be secure. So there are different approaches that we have for securing the web traffic. One general approach is incorporating the security at the IP level. in the form of IP security. So when you go for IP version 4, we can make use of IP security so that you can secure all the communication that goes on between any two parties. So for all whatever communication that can go on, you can secure it by making use of IP security. So the advantage with this IP security is it is transparent to the end user, and the end user need not have to learn about how this IP security is working and all. It is transparent to the end applications also. So that's the advantage that we have with IP security. So IP security generally is implemented at the network layer, above the network layer, that is IP layer. So whatever data that you are going to transmit here from your application will go to after going to the transport layer, that is the TCP protocol, that will be giving the data to the IP security, wherein you can secure your whatever data that you want to transmit, that can be secured by making use of IP security, and that will be given to the IP layer, where it encapsulates to a packet and then transmit it to the other end. So it is not just that between whatever data that you want to secure, that gets secured here. Rather, when you implement this particular IP security at the firewall of your network, then all the traffic which leaves your firewall can be secured by making use of this IP security. So this is one way of securing all the traffic, all the data that you are going to transmit to the outside world from your network. The other way of securing the traffic, providing web security, is implementing this this level of security above the TCP in the form of SSL or in the form of TLS. So secure session socket layer, or it can be transport layer security that you are going to incorporate just above the transport layer. So whatever data, application data that comes in, that there you are going to provide security at this SSL layer, and that will be given to the transport layer for transmission. So this is where you are going to implement the security features above the TCP protocol. And the other one is you can provide security to the security based on the applications. Like for example, if you want to secure your emails, you can go ahead with either a PGP protocol, or you have PEM protocol, or you can go for SMIME. So these are the various applications wherein you can secure your email application. So these are the various security protocols that we have wherein you can secure your email applications. So that is specific to particular application. And when you want to secure the communication, or when you want to provide authentication between the user and the servers and various other servers that the users have an account, so he need not have to go to each and every server requesting for requesting for the data. Before that, he has to get authenticated to various servers. So that can be reduced by making use of what is known as a Kerberos, wherein you can just authenticate yourself to the authentication server or the Kerberos server. Once that is done, then it issues a ticket to the ticket granting server, and this ticket granting server will, making use of the ticket to the ticket granting server, this particular user can get the tickets to various other servers. Like, in the sense, only one authentication, you are going to authenticate yourself to the authentication server. Once this is done, you can access any other servers making use of the tickets that are being issued by this Kerberos server or the ticket granting server. So these are the applications that we have, which is specific to that particular application. But in general, when you want to provide security to all the IP traffic, then we can go ahead with IP security. And when you want to provide security to your web to your web applications are something like you can go ahead with SSL or the TLS protocol specifically about the transport layer. So these are the various means wherein you can secure your web traffic. So pertaining to certain applications, or it can be all the traffic can be secured by making use of IP security. So IP version 4, it does not provide any sort of security as such. So you need to incorporate when you want to secure your communication, all the IP packets that are going out from your particular node or from your network. If it is so, you have to install it at the firewall. If it is done, then all the traffic that moves out from that particular node, goes out from that particular node or from that particular server, will be secured by making use of this IP security. And when you go for IP version 6, this IP security is being mandated over there. So, so all the packets will be secured by making use of this IP security, which is embedded in IP version 6. So in IP version 6, security is mandated, but when IP version 4 was introduced, they did not keep the security into mind, and hence they have incorporated, they have come up with IP security protocol wherein you can install it in the TCP IP stack above this IP so as to secure all the traffic that goes on from your network to the others or something. So here we'll be concentrating mostly on this particular SSL or the TLS, which provides security to your web applications. So when you go for this SSL protocol, so this is secure socket layer protocol that we have, so which makes use of the transport layer service. So that is above the transport layer protocol. Transport layer, you're going to have this particular protocol being installed in the TCP IP stack here. So this runs over the TCP protocol, as HTTP protocol mostly makes use of the TCP protocol for transmission of the messages. So this runs above the TCP protocol. So SSL, it is a transport layer security protocol, and this has been originally developed by Netscape for securing the communication between the Netscape Navigator, that is the web browser, and the server. For that, they have developed this particular SSL protocol. But this SSL protocol initial versions like the SSL version 1 and version 2 are being specific for that particular company itself, and they have not taken the public view into account, but they have developed those two versions. Later, version 3 is being designed with the public inputs, getting the inputs from the public. They have designed this version 3, and this SSL version 3 is not an internet standard, rather the subsequent this particular SSL, when it is being standardized by the IETF community, then they made this as a TLS. So SSL version 3.1 is what is TLS, which is the standard, internet standard for transport layer security. So this uses TCP to provide reliable end-to-end communication. So this runs above the transport layer, where at the transport layer it runs this particular TCP protocol. So what does this SSL offers? So you need to, as we said in the previous cases, the attacks that are possible are some sort of modification attacks are possible, or the masquerading attacks are possible, or it can be the interception. So we all know that when you want to counter this eavesdropping, the traffic that is being transmitted between the two endpoints should be secured. In the sense, you need to secure this by performing some sort of encryption, where you are going to go for some sort of encoding or something like this. So for that, you need to make use of some cryptographic algorithms wherein you can secure your data that is being communicated. Mostly when you go for providing confidentiality to the data, we all know we'll be making use of symmetric cryptographic algorithms rather than asymmetric cryptographic algorithms. Why symmetric and why not asymmetric algorithms? Symmetric algorithms are being used here because they require less computation time when compared to that of the asymmetric cryptographic algorithms. So when you go for asymmetric cryptographic algorithms, the computations involved in asymmetric cryptographic algorithms are very high when compared to that of symmetric cryptographic algorithms. Say for example, RSA algorithm. So when you want to encrypt the data, making use of this asymmetric cryptographic algorithm like the RSA algorithm, the encryptions are being done by making use of exponential operations, which takes a lot of computation time. But whereas when you go for symmetric cryptographic algorithms, we all know they include simple operations like exclusive OR operations, maybe some sort of permutations or some sort of S-box substitutions that we have. So those are the simple operations that are being used when you go for symmetric cryptographic algorithms. And hence mostly we'll go for symmetric cryptographic algorithms for providing confidentiality to the data. So in order to provide confidentiality to the data, as we said, we are going to make use of some sort of block cipher algorithms or some symmetric cryptographic algorithms. When you go for the symmetric cryptographic algorithms, we need to say that both the two end parties, both the sender and the receiver, are both the client and the server, they should make use of the same key for both encryption, and at the other end for decryption, the same key has to be used. So this particular key, how are you going to distribute? That is a problem here. So when you make use of symmetric cryptographic algorithm for providing confidentiality, the key has to be established for securing this communication between the client and the server. So the key management or the key exchange is one of the topics that has to be taken up when you want to provide confidentiality, because between any browser and the server, generally we won't make use of the same key repeatedly for any number of times. Rather, for every session, a session key has to be established for any session between the client and the server. Why? Because if you make use of the same key for days together, there is a chance that the cryptanalyst or the attacker, he'll have lot of ciphertext at his disposal, and this by making use of this ciphertext, large amount of ciphertext, it will be easy for him to cryptanalyze and get the key here. So that should not be the case. In order to reduce that, what you are going to go for is, for every session we are going to establish a new key. So a session key has to be established. So for this particular session, you are going to make use of one particular key here. So that session key has to be established here. So how are you going to establish this particular session key? That is of much importance here. Why? Because we are making use of symmetric cryptographic algorithm for providing confidentiality. In order to make use of this symmetric cryptographic algorithms, a key has to be used here. So you need to establish a key. So for that you require a key exchange algorithm to be run between the client and the server before you provide confidentiality to the data. And also we said that there are some other attacks like the modification attack, or there are some attacks like masquerading attack. So these also you need to overcome. So in order to overcome this, what is required is you need to go for ensuring the message integrity service and the authentication service. So in order to authenticate, or in order to ensure the integrity of the data, generally we make use of message authentication codes over there, wherein that also requires some sort of key here. So that key also has to be established between the two communicating parties. And when you are exchanging the key, maybe you can make use of asymmetric cryptographic algorithms when you want to exchange the key. So that is, we can make use of this algorithms like RSA algorithm, or it can be Diffie-Hellman key exchange algorithms that can be used for exchanging the keys here. So that is a public key cryptographic algorithms that you are making use of. So when you are making use of these public key cryptographic algorithms, you need to learn the other public keys you need to get the other public keys. what is required is you need to have some sort of digital certificates being issued by the certification authorities. So that can that certificates issued by the certification authority can in turn ensure that a particular public key belongs to so and so user. So to provide confidentiality, you need to have a key. That key has to be established by making use of asymmetric cryptographic algorithms like a RSA algorithm, or it can be Diffie-Hellman key exchange algorithm or some other algorithm. So making use of that, you need to exchange the keys first. Once the key is established, then you can go for securing your information. And before that, they have to get authenticated each other. So first, the server and the browser and the server, they need to authenticate each other. So they need to ensure that they are talking to the other persons only and not to any other. That should be ensured by making use of this authentication mechanism. So the other thing is you need to ensure the integrity of the data. So when you are ensuring the integrity of the data, generally we make use of message authentication codes here. So these message authentication codes are one-way functions that we have. So similar to that of the hash functions, wherein whatever may be the size of the message that is being given, it generates fixed size output. So that output has to be whatever output that you are going to have. So that output has to be encrypted by making use of one key. So this is a keyed hash functions that we have. That is what we call it as a message authentication codes. So because this particular key will be known only to the sender and the receiver, then they can be assured that the message has originated from a particular source. In this way, you can also provide authentication to the data. And this integrity will be ensured by calculating the MAC over message that is being transmitted to the other end, and along with the message, this MAC also gets transmitted. At the receiving end, what you are going to do is calculate the MAC over the received message and check whether the received MAC is equal to the calculated MAC or not. If these two are same, then the other end, the receiver, will be ensured that the message has not been altered during the transmission. In this way, you can ensure the integrity of the message. So for that, what is required? In the MAC also, you require some sort of keys. Some key that has to be used for generating the message authentication code. So you need to exchange the message, these two codes, like the key exchange has to be done for encrypting the data, and also for generating the MAC you require a key that has to be established. So, and also whatever message that you are going to transmit, you are saying that we are going to make use of block cipher algorithms for providing confidentiality to the data. When you do so, whatever may be whatever size of the message that you have, it cannot be encrypted at a time by these block cipher algorithms. So block cipher algorithms, they encrypt the data in blocks, maybe of 64 bits, or it can be 128-bit block, or like this. So whatever message that we have, it can be more than this block size here, and hence what you have to do, you have to encrypt. You have to make use of one or the other modes of operation for encrypting this particular data. Generally, we make use of cipher blockchaining mode for encrypting the data. If that is the case, when you make use of cipher blockchaining mode, you need to make use of one initialization vector. So for that, you require to establish an initialization vector that has to be used for encrypting the first block, and then the previous cipher block can be used for encrypting the subsequent blocks here. So an initialization vector also has to be established between the sender and the receiver. So you require to generate 3 keys. One key is for providing confidentiality to the data, and one key is for ensuring the integrity of the data, and the other value is the initialization vector that has to be established between the two communicating parties here for secure exchange. And these 3 keys will be for the communication will be on the both sides, right? The client sends the information to the server, and the server in turn responds to the client. So in order to secure the communication, we'll be making use of these 3 keys for one direction, from client to server, we'll be establishing these three values: encryption key, MAC key, as well as the initialization vector for the communication from the client to the server. And for the reverse traffic, from the server to the client, you need to establish again these three keys: encryption key, integration MAC key, as well as you need to establish generate the initialization vector. So on the whole, we need to generate 6 keys that are to be used for encryption, for ensuring integrity, as well as when you are going for encryption, and when you go for cipher blockchaining mode, which is the mode that is being standardized for this communication, you need to have an initialization vector. So totally 6 keys are to be established between the client and between the web browser and the web server before they go for actual secure communication here. So how are you going to generate these keys first? Then we'll go into how actually the confidentiality and the integrity is provided in this SSL. So these are the various key exchange algorithms that are being supported to go for this SSL protocols. So we said that you need to generate 6 values here. So how are you going to generate? So first, between the two communicating parties, first a pre-master secret will be established by making use of this key exchange algorithms. So the first one is null, where you are not going to establish any pre-master key between the two communicating parties. That is the first one, that is null. So both the server, client and the server need to know the value of the pre-master key before they go for that is being static, in the sense they have already communicated this pre-master secret, and that they are not going to go for any key exchange algorithm at present. So they already have the pre-master key that has been established. In those cases, they can go for this null key exchange algorithm. So the other algorithm is the RSA algorithm. So when you go for this RSA key exchange algorithm, the client itself, it generates a pre-master secret, and that will be encrypted with the server's public key, and that will be transmitted to the server. As this is encrypted with the server's public key, only the server can decrypt it with the corresponding private key, and hence it will be secured from unauthorized access. So this key, when it is encrypted with the public key of the server and is transmitted to the other end, the server will decrypt it with its private key, and that pre-master secret key is being established between the two communicating parties. That is making use of RSA algorithm. So the other algorithm is the anonymous Diffie-Hellman key exchange algorithm. So all these algorithms are public key cryptographic algorithms: RSA, Diffie-Hellman, Diffie-Hellman key exchange algorithms are the public key algorithms. So when you go for this anonymous Diffie-Hellman key exchange algorithm, so this is how you are going to establish a pre-master secret key. So first, the server generates a prime number P, and then it generates a primitive root of this particular prime number G, and then it generates its private key S, and then it generates the public key by raising this primitive root to S, G to the power of S mod P. That will be the server's secret that you are going, server's public key, and that is being transmitted to the client. Now the client also makes use of these two values, G and P, and then it generates its own public key by raising this G to its private key C, and that will be transmitted to the other. So both of these, they'll be generating the key by raising by raising the received public key of the other party with their private key. That is, the client will receive this particular G to the power of S value. So it raises G to the power of S to its private key C. Thereby it will be getting G to the power of CS into CS mod P. And at the server's end also, whatever it receives, G to the power of C mod P, that will be raised to the power of S. Thereby, it will be generating the same value g to the power of c into s mod p. So this is how you are going to establish a pre-master secret key when you go for this anonymous Diffie-Hellman. Why we call it as an anonymous Diffie-Hellman here is neither the parties will be aware of the other here. In the sense, anyone can impersonate as if he is some X and then send this information to the other party. So the other party will not be aware whether it is getting the data from a particular person who is a genuine person or maybe an imposter person. So that will not be known to the server. That is what we call it as a man in the middle attack. So this man in the middle, what he does is he impersonates himself as a client to the server, and then he can impersonate as a server to the client. So in order to overcome this, which happens in this anonymous key exchange algorithm, we go for the alternatives like ephemeral Diffie-Hellman key exchange algorithm or a fixed Diffie-Hellman key exchange algorithm. So when you go for ephemeral Diffie-Hellman key exchange algorithm, so here what you are going to do here is the server, when it generates this Diffie-Hellman parameter, the key parameters g, p, and g to the power of s. Here in this particular case, it is transmitted in the raw format. Rather, now it will be signed by the server. Signature in the sense, so here it is not server's private key. It is so sign with its private key. So this encrypts this particular information. The server encrypts g, p, and g to the power of s mod p with its private key, and then it will be transmitted to the client. Now the client accesses the public key and then it verifies this particular signature of the server. Thereby, it will be getting the information. And also the client, when it transmits this information, it signs the information and then transmits it to the other end. So with its private key, it is going to encrypt this information, and that has to be verified by the server with the client's public key. Thereby, even if there is a man in the middle attack also, he'll be verified, he'll be identified as if he is some other person, not a client or not a server. So he'll not be able to impersonate either the client or the server to the other parties here, because the signature is being generated by the corresponding server and the client. If at all he generates a message and encrypt it with its private key, then it will be known that it is not being encrypted, it is not being signed by the client or the server, rather it is being signed by the man in the middle. Thereby you can overcome this particular attack that happens with the Diffie-Hellman key exchange algorithm. Pre-master key is calculated in a similar way when you go for this g to the power of cs mod p. So that is what you can make use of. So for generating this signatures, you can make use of either RSA algorithm or you can go for a DSA algorithm. Digital signature standard can be used. DSA algorithm, digital signature algorithm can be used, or we can go for RSA algorithm for generating this digital signatures here when you go for ephemeral Diffie-Hellman key exchange. The other way where you can defend this anonymous man in the middle attack that happens in anonymous Diffie-Hellman key exchange algorithm, that can be done by making use of this fixed Diffie-Hellman key exchange algorithm. So what you are going to do here is all the entities in a group will have the prefixed Diffie-Hellman parameters like g and p, where p is a prime number and g is the primitive root of this p that you are going to generate, and that will be known to everyone in the group. So what everyone does here is making use of these two parameters, they generate their public keys. That is, they generate a private key, some x say, then they'll generate their public key correspondingly by raising this g to the power of x mod p. So like this, they'll be generating the public key, and this public key will be certified by the certification authority, saying that this particular public key is so and so belongs to so and so user here. Like this, you will be getting the certification authority. So each entity half key is certified. That is their public key that is used in generating this pre-master key will be certified. That is G to the power of S will be certified as if it belongs to the server, and G to the power of C will be certified. This is the public key that will be certified of the client, that will be certified by the certified that it belongs to the client by the certification authority. That is half of the key will be certified by the certification authority, and they'll be exchanging their certificates. When they exchange the certificates, they can get these particular values, and then they can generate the pre-master key. Instead of getting signed, instead of this messages being signed by the party itself, rather the signature will be done by the certification authority, who will be trusted by both the client as well as all the parties in that particular group, and hence they can have the key exchange, pre-master key, that can be established by making use of the certificates which are being issued by the certification authority. So the other key exchange algorithm apart from these 5 is a FOTISA algorithm. So no much discussion on FOTISA algorithm that you are going to go for, as it is a registered trademark of US National Security Agency, and it is a family of the security protocols being developed for the Defense Department. So generally we make use of the other 4 algorithms. Even FOTISA is also supported, but later in TLS, FOTISA is not being supported by TLS. When you go for, so that is what, so we will be generating the pre-master key, and from this pre-master key we have to generate the master key, and from the master key we will be generating the actual keys that you are going to derive. So now we said that when you want to provide message confidentiality, you are going to make use of some block cipher or the stream cipher algorithm, some symmetric cryptographic algorithms. Either it may be block cipher or a stream cipher. So both block cipher and stream cipher are being supported by SSL protocol. So like the encryption algorithms can be null, you may not be making use of the encryption algorithm at all, or it can be a stream cipher in the form of RC4 algorithm. This RC4 algorithm is supported by SSL with a 40-bit key, or it can be a 128-bit key. So this RC4 algorithm is a variable length key algorithm that we have. It can support, we can make use of either RC4 with 40-bit key, or it can be RC4 with 128-bit that can be used here. And the other block cipher algorithms that are supported are RC2 algorithm. So this RC2 algorithm, as we said, when you go for a block cipher algorithm, we need to go for some mode of operations. The mode of operations that is being standardized is CBC mode. So when you go for this CBC mode, RC2, we go for a CBC mode, and that it goes for a 40-bit key. This is how you are going to make use of this RC2 algorithm. Or you can make use of a DES algorithm with a 40-bit key, and this mode is CBC mode, or it can be DES algorithm. Actually, it is a 56-bit key that you are going to make use of. So it can be either DES algorithm with 56-bit key, or and CBC mode is the one that is being used over there. And the other algorithm that is supported is triple DES algorithm, where it goes for a EDE concept, where encryption making use of the DES, and then decryption with DES, and then followed by encryption with DES. That is three DES algorithm that you are going to have, and that also goes ahead with a CBC mode, cipher blockchaining mode. So these are the various encryption algorithms under DES that are being supported by SSL. The other algorithm that is supported is the IDEA algorithm. So IDEA algorithm in CBC mode, that is also supported by SSL. The other algorithm is a block FOTISA algorithm is also supported, but this is a as we said previously, this is developed for the US national security agencies, and then this is Forteza algorithm with CBC mode that can be used. So these are the various encryption and decryption algorithms that can be used. And also we said that when you go for message integrity, you are going to make use of MAC algorithm. Like mostly the HMAC algorithm, you are going to make use of hashed MAC that you are going to have, where you are going to make use of hash functions over there. So the hash algorithms that you are going to that are being supported in this SSL are maybe null, or that is you are not making use of any hash functions, or it can be either MD5 algorithm or SHA-1 algorithm that is being supported, message digest 5 algorithm, or it is a secure hash algorithm that is being supported. So these are the two hash functions that are being supported when you go for this SSL algorithm. So the cipher suit it defines. So all this we said, we are going to make use of key exchange algorithms, and then we are going to go for encryption algorithms, and then hash functions in order to provide confidentiality and integrity to the data that is being transmitted between the client or the web browser and the web server. So for this, you require to make use of these algorithms. So before the client and the server goes ahead with secure communication, they need to come to a conclusion regarding what sort of algorithms they have to use for key exchange, what algorithms have to be used for encryption, what hash functions have to be used for providing integrity and confidentiality, authentication to the data. All this has to be exchanged before they go for actual secure communication. So that will be in the form of a cipher suit. So the combination of this key exchange algorithms, hash function, and the encryption algorithms, they define what is known as a cipher suit, and that will be used for every SSL session that you are going to have. So when you are establishing a session between the browser and the client, making use of this SSL, they need to come to a conclusion regarding this particular cipher suit. That is, what is the key exchange algorithm, what are the hash functions, and what are the encryption algorithms that are to be used. So both the client and the server, they should negotiate on this, and then they have to attain at a particular cipher suit that has to be used here. So this cipher suit will be specified like this. So SSL is the protocol. So in that, the first DHE RSA. So this is the nomenclature that is being given for this particular key exchange algorithm. Diffie-Hellman key exchange, Diffie-Hellman algorithm with ephemeral Diffie-Hellman algorithm. DHE is ephemeral Diffie-Hellman algorithm, and that makes use of RSA algorithm for generating the signatures with DES algorithm with CBC mode. This is the encryption algorithm, then followed by what is the hash function that you are going to make use of, _hash. So this is the cipher suit that you are going to establish here. So that has to be established between the client and the server. So these are the various SSL cipher suits that are possible based on the previous algorithms. Like we have seen 6 key exchange algorithms that are possible, and we have seen like 6 encryption algorithms that are possible, including null, and then we have seen the 3 hash functions, hash algorithms that can be used here. So all these they lead to these number of cipher suits that are possible. So optionally, whatever data that you want to transmit can also be compressed when you go for SSL protocol. So SSL, this is optional. Compression is optional when you go for SSL version 3, and there's no specific compression algorithm that is being defined for SSL version 3. But you can exchange before you go for the actual negotiation along with your cipher suit, you can also specify that these are the compression. This is the compression algorithm that that can be used for compressing the data before they go for encryption. That can be negotiated on. So the default compression method is null because it is optional when you go for SSL protocol. So these are the various algorithms that has to be negotiated before they go ahead with the secure communication here. So now we said that when you go for this keys, when you are making use of block cipher algorithm, or it may be a stream cipher algorithm, the symmetric cryptographic algorithm, for secure communication, you need to have a key that has to be used for encrypting the data that originates from the client to the server, and for the reverse traffic from the server to the client, you need to have one particular key. So two keys have to be used for generating for providing confidentiality to the data, for encrypting the data. So you need to generate two keys. So here we'll be making use of a term known as a read key and a write key. So read key in the sense, so when the client transmits the data to the server will be reading the data that is coming from the client. So for that, as this is encrypted by the client, it has to be decrypted with the corresponding key from the client, and hence it makes use of the key which the client has used for encrypting. So that becomes the write key for client, and that is same as the read key for the server. And for the reverse traffic, the server encrypts the data with its write key, and that has to be decrypted by the client with the same key, and hence it forms the read key for the client. So I hope it is clear to you all. A read key and a write key. So when the client transmits the data to the server, it encrypts this data with a key, and that key is known as the write key for the client, and the same key is known as the read key for the server. And for the reverse traffic from server to the client, it will be a write key for the server, and same is the read key for the client. So you need to have two keys to be established between the two communicating parties for duplex communication. One for the traffic from the client to the server, and one key for the traffic from the server to the client. So to generate this, and also you need similarly the MAC keys also. MAC write secret, server MAC write secret becomes the client reads MAC read secret, and client's MAC write secret becomes the server's MAC read secret. So like this, you need to generate the keys, and also you need to have the initialization vectors that are to be established as we are making use of cipher blockchaining mode. So so in the previous case, when you go for this, when the key exchange is being done, you are establishing a pre-master key. Pre-master key is used in generating the master key. So this is the cryptographic procedure for generating the master key from the pre-master key. So this PM is the pre-master key that is being generated making use of the key exchange algorithm. So from there you are going to generate the master key. So this master key is generated making use of this particular procedure. So these are the constants. A is a constant, BB is a constant, and CCC is a constant. Those are the predefined constants that are being used when they are generating the master key. So this constant concatenated with the pre-master key that is established making use of the key exchange algorithm, followed by a client random number and the server random number. These two will be negotiated before they establish a session. Between the client and the server, before they establish a session, they have to exchange these two random numbers. So these are the client random number, and this is the server random number. So all these are hashed, making use of a SHA-1 algorithm. And the output of this SHA-1 algorithm, whatever may be the size, it results in 160-bit output. So So that is the hash that you are going to have. So this hash, along with, again, you will be taking this pre-master key. So the pre-master key is concatenated to this hash value, and then again you are going to generate the hash value, making use of this MD5 algorithm. So that resultant hash is concatenated to the next hash. The next hash is generated by making use of this constant BB, then the pre-master key, the client random, the server random, then again the same procedure is being followed like this, making use of three different constants, that is A, BB and CCC. You are going to generate three different hash values. All these hash values are concatenated together. That results in a 48-byte key. That is, from every hash, so this MD5 algorithm, it generates 128-bit hash here. So SHA-1 generates 160-bit hash value, and MD5 generates 128-bit hash value here. So 16 bytes is the hash value that is being generated by every MD5 algorithm. All these things are combined, that generates a 48-byte hash value. That is what we call it as a master key. And making use of this master key, you will be generating all these values like client write key, server write key, client write MAC, server write MAC, and then the initialization vectors, client initialization vector, server initialization vector. All this has to be generated by making use of this master key. So how are you going to generate that? So this is the procedure for generating the key material from this master key. So the same procedure that has been adapted previously, when you go for calculating the master key, the same thing is adapted, except that the pre-master key is replaced with now by the master key. So then you will be generating the hash values here. So how many values you have to generate, those number of times you are going to repeat here with different different constants over here, and that will be generating the key material. So based on the algorithm that you are going to make use of, say for example, we said DES with 40-bit key is also used, or DES with 56-bit key is used. So based on the size of the key that is being used for the algorithms that you have negotiated on, these keys has to be generated. So this can be repeated until you generate the required key material. So from this key material that you have generated, you are going to derive these six keys, these six values that we said here. So the one is a client authentication key, or we call it as a client MAC key. So that is the first value that you are going to make use of, and that depends on what sort of algorithm that you are making use of here. So then the server authentication key, then client encryption key, the server encryption key, then these two initialization vectors. So these are the, maybe that initialization vectors also depends on the algorithm. So if it is a DES algorithm that you are making use of, it goes ahead with 64-bit key, 64-bit initialization vector that is being used. So based on the algorithms that you have negotiated on, all these the sizes vary here based on the algorithms that you are going to make use of. So in this way you are going to generate these 6 values that have to be negotiated, that will be negotiated. So once you decide on what is the key exchange algorithm, what is the encryption algorithm, and what is the hash function that you are going to make use of, then the sizes of these keys will be known to both the sender as well as the receiver, and making use of these random numbers that are being negotiated, they will be generating these keys. So they'll be independently generating these keys at both the ends, and that keys will be used for secure communication between the browser and the server. So when we go for this SSL architecture, previously we were saying that you need to have this key exchange to be done. Once the key exchange is done, then you are going to go for encryption, providing confident integrity to the data. For this, you need to go for these sort of algorithms and all. So before that, they have to negotiate on this cipher suit. So that is what we do in the form of a session. So what is a session? A session is an association between the client and the server, and that will be created by making use of a handshake protocol, wherein both the client as well as the server, they'll be defining a set of cryptographic parameters. That is, the cipher suit will be negotiated. Also, they can negotiate on compression algorithm if they are making use of that particular any compression algorithm. So this has to be negotiated on. So that defines this. If at this particular session, these are the algorithms that are to be used, that will be specified in a session. So they define a set of cryptographic parameters, and they can be shared by multiple SSL connections. So SSL connection is similar to that of a transport connection that you are going to have between the two parties, client and the server. So you can have n number of connections over a single session, but every connection will be associated with only one session. So SSL connection is a transient peer-to-peer communication link that you are going to have. So when you go for this session, in a session, one party takes the role of a client and the other party takes the role of a server. So the client has to make a request. In any case, when you go for a client server application, always the request goes from the client to the server, right? So one has to act as a client, and the other party will take the role of a server when you are establishing a session. Once the session is established, any party can go for can take the lead in establishing a connection. So both the parties are equal and they are treated as peers when you are establishing a connection over a particular session. So this is the difference between a session and a connection. So a session is established between the client and the server, and in this session the clients can establish n number of connections with that of a server. That is, the cryptographic suit that you are going to establish will be same. Later you can discuss on when you are exchanging the keys and all, you can when you are establishing when you want to communicate, you can communicate it on different connections over this particular session. So what are the session state parameters? So when you look at what are the parameters that we have in the session state and to indicate the session state and the connection state, we can clearly distinguish what a session is and what a connection is. So these are the various session state parameters. So every session will be identified by a session ID. So that is a random number that is being chosen by the server. So a server will be choosing a 8-bit number for this particular session, and then the other parameters are the peer certificates. So as we said, they are making use of public key cryptographic algorithms for exchanging the key. Then they need to exchange their certificates for getting the public keys of the others here. So a certificate of type X.509 version 3, which are the standard certificates. This is the standard certificate format that is being described in this X509 version 3. So these certificates can be exchanged. So if at all they do not want to authenticate each other or something, then they need not have to exchange the parameters. Exchange these particular certificates. So the next thing is compression method. So what is the compression algorithm that has to be used for compressing the data between the client and the server? And then cipher suit. So this is the agreed upon the cipher suit, which includes key exchange algorithm, encryption algorithm, and the hash functions. So all this will be in the form of a cipher suit for that particular session. And then you are going to establish a master secret that we have seen previously. So this is the master secret that you are going to establish, which is of 48 bytes that we have seen. And then is resumable. This is a SNO flag which specifies whether you can allow the new sessions on this particular session or not in an old session. So this is these are the parameters that we have in the session. And when you come for the connection state parameters, these are the various parameters like so this session, it specifies what is the cipher suit that has to be used and what is the master key that has to be used. Later, based on the when you are establishing a connection, they'll be negotiating on this client random and the server random. Based on that, you are going to derive the keys that are to be used, the keys and the initialization vectors that are to be used, that is specific for a particular connection. So these are the various connection parameters. Server and client random numbers. These are the sequence of bytes which are chosen by the server. That is server random number, and the other one is a client random number. For every connection, they will be exchanging this. Then we have seen from the master key how we are going to generate the server write MAC key and the client write MAC key, server write secret and the client write secret. All this will be established between the two communicating parties by making use of the algorithms that we have already specified previously. And these 6 values, initialization vectors also, or initialization vectors are required when you are making use of this CBC mode. So all these 6 values will be generated by making use of the algorithm that we have mentioned previously, that is specific to a particular connection. And when the data is being exchanged, that will be exchanged in the form of the packets. So you need to keep track of this messages that are being exchanged. For that, you require what is known as a sequence number. So every party, when they are communicating, they can have their own sequence number, similar to that of a transport protocol, TCP protocol. In that also, when you are establishing a connection, both the parties, they have their own sequence number, starting sequence number. In this way, you can also have the starting sequence number for the client and the server, and they keep on incrementing. So the size of this sequence number is the total number of bits that are being allocated for this sequence number is 64, and hence it should not exceed 2 to the power of 64 minus 1. So 0 to 2 to the power of 64 minus 1 can be used, and once this is exceeded, then maybe you need to drop that particular connection and a new connection has to be established between the two communicating parties, so that you can overcome this sort of replayed attacks, like the delayed packets that are being exchanged. That sort of attacks can be overcome if you terminate the connection once it exceeds this particular limit 2 to the power of 64 minus 1. So these are the connection state parameters. So now I hope you know what is the difference between a session and a connection. So in a session, you are going to specify the cipher suit and you are going to derive the master key. Once the master key is derived, then based on the connections, they can generate all these 6 keys based on the server and the client random number that is being negotiated on this particular connection. So you can have n number of connections being established over a session. So the client and the server, as we said, has 6 different cryptographic secrets, 3 read secrets and 3 write secrets. So the read secrets for the client will become the write secrets for the server, and the write secrets of the server will become the read secrets of the client. So this is the architecture of SSL. So we said that we need to exchange the cipher suit, and once the cipher suit is exchanged, then you are going to establish all the 6 keys that are required. Once that is done, then you are going to go for encryption, or you are going to provide integrity to the data. So all this structure, all these algorithms that we have seen so far, the protocols that we have seen so far, so is being layered in 2 layers when you go for this SSL protocol. So SSL is a 2-layered protocol. So at the bottom layer is the SSL record protocol. So this SSL record protocol, it offers the basic security services like the confidentiality and integrity will be ensured by SSL record protocol. And above layer protocols are SSL handshake protocol. This is the protocol which which is used for establishing a session between a client and the server. And the next protocol is the SSL chain specification protocol. So whatever parameters that are being exchanged in this handshake protocol will be will come to active stage only after running this particular SSL chain cipher specification protocol. Generally, at the end of the handshake protocol, SSL chain cipher specification protocol will be running, so that this pending state, whatever that are being negotiated, which are in the pending, will come into active stage only after running this chain cipher specification protocol. And then it is followed by and then we have another protocol known as a SSL alert protocol. During the message exchanges, if at all any exceptions happen, any errors happen during the transmission, then it should be intimated to the other party, and that can be done by making use of this SSL alert protocol. So these alerts can be some sort of fatal alerts, or they can be warnings. If at all you have a warning, it can be ignored, but if you have a fatal alert, then that particular connection on the session on which this particular exception has happened should be deleted. So the connection will be terminated once you have a fatal alert, and then no more connections can be established over that particular session once a fatal alert has happened on a particular connection. So the connection will be terminated and no more connections will be allowed on that particular session once a fatal alert happens. So these are the three protocols which are run above this SSL record protocol, which offers the basic security services. So when you want to establish secure communication between the client and the server, then you are going to go for this SSL handshake protocol. So when you go for this SSL handshake protocol, it establishes a session between the client and the server. So this is how you have like the application layer protocol, that is the HTTP, it can directly communicate with whatever data that, so for the record protocol, the data can come from the SSL handshake protocol, or it can be a chain cipher specification protocol, or it can be from the alert protocol, or it can be the application data in the form of HTTP data request or the reply that you are going to have, that will be embedded in the record protocol format here, and then that will be given to the transport layer for transmission. So what is that you are going to do in this SSL handshake protocol? So this SSL handshake protocol, it allows the client and the server to authenticate each other and to negotiate on what are the encryption algorithms and the MAC algorithms and the key exchange algorithms that are to be used, and the master key will be negotiated between the two communicating parties here. That will be done by making use of this handshake protocol. So this handshake protocol, while it is being, while a session is being established, there are a series of messages that will be exchanged between the client and the server when it is establishing the session. So there are four phases generally that we have in this SSL handshake protocol. The first phase is where they are going to establish these security capabilities, like what algorithms have to be used for key exchange, for encryption, for the hash function. All this will be exchanged during the first phase. So establish security capabilities. Once this is done, then the server can authenticate itself. Optionally, it can authenticate itself to the client, and then it exchanges its key here. And the other one is client authentication. Next phase is client authenticates itself, and then a key will be established here. So the next phase is the finish phase, where both the parties have to come to the conclusion regarding the cryptographic algorithms that they are going to make use of. So then it comes to the finish state. Once the keys are intact, then you are going to go for a finish state. where in the finished state you are going to run this particular chain cipher specifications protocol. So when you go for this handshake protocol, this is the format of the handshake protocol that we have. So what is the type of the handshake? There, as we said, there are a series of messages. Every message will be indicated by what type of message that is being transmitted. Then followed by the length, which specifies what is the length of this content, then followed by the content. So this content size can be 0 for some messages, and it can be more when you go for other messages here. So this is the format of SSL handshake protocol data. So as we said, SSL handshake protocol has 4 phases. In the first phase, they'll be establishing the security capabilities. The second phase is the server authentication and key exchange. Third phase is client authentication and key exchange. And in the final phase, both of them will be moving their pending state into current state by running this chain cipher specifications protocol. So this is the first phase of handshake protocol, where you're going to establish the security capabilities. So when you go for, say, establishing the security capabilities, first the client initiates the communication by sending a request to the server for establishing a session. So for that, first client sends a client hello message in which it specifies what is the latest version of SSL that it is supporting. Latest version of SSL that it is supporting. And then it sends client random number. A client random number, it generates a random number, and that will be transmitted to the other. So a client random number will be generated, then the session ID. If it is establishing a new session, the client generates this, client sends this session ID as 0, because it is the ID that will be generated by the server. And hence, if it is a new session, it generates it as 0. But if it wants to go ahead with a new connection over the existing session, then it can go ahead with of that particular session ID. Then if at all it wants to change the cipher suit of that particular session, then it sends the session ID. Previous session, the session ID of that particular session over which it wants to update the cipher suit on the computer. So then followed by the cipher suit, which specifies what are all the cryptographic algorithms that it is supporting for encryption, hash functions, and for key exchange. So what are all the algorithms that it supports will be transmitted in the client hello message in the cipher suit. And what are all the compression algorithms that it supports also will be negotiated, will be transmitted in the form of client hello message to the server. Now, after getting this, the server makes use of the latest version. Say, for example, the client is supporting SSL version 3, and this is also supporting SSL version 3, then that is the latest version, so it makes use of that particular version. And then the other one is it generates its own random number, its own nonce. So that will be the server random number. So that will be generated by the server, and this session ID, if it is a new session that is requested by the client, it generates a session ID which is not being used previously. That session ID will be generated, and that will be sent in the form of a server hello message along with, from the cipher suit, whatever cipher algorithms that are being supported by the client, it selects one among those algorithms, the best among those algorithms, and then it sends in the server hello in the form of selected cipher set. And also from all these compression methods that are being supported by the client, it selects one among these that has to be used for this particular session. So that is selected compression method. So all these bundled together will be transmitted from the server to the client in the form of server hello message. So like this, the capabilities of the security capabilities will be established between the client and the servers. So by this time, they come to the conclusion regarding the cipher suit and the compression algorithm that has to be used. So once this is done, then the the handshake protocol enters into the second phase. So after the phase 1, the client and the server will be knowing what is the version of the SSL that has to be used and what are the algorithms that are to be used for key exchange, for message authentication, or that is message integrity, and that is MAC algorithm, or the hash function, and the encryption algorithm. And they'll be knowing what is the compression method that has to be used. And then there are two random numbers that are being exchanged. That is client random and the server random that are being exchanged over here. Then in the next phase, in the phase 2, this is server authentication and key exchange. So this goes like this. So first, the server can optionally send its certificates. This is optional. Authentication is optional. The server can transmit its certificates. When it is transmitting its certificates, it can be a chain of certificates that it can transmit. Why? Because both the server and the client may not be certified by a common certification authority. If they are not certified by a common certification authority, then they should have a sequence of a chain of certificates wherein both these parties, both the server and the, say for example, X has certified Y and Z, and the client is certified by Y and the server is certified by Z. Then Y is not known to the server and Z is not known to the client. But this Y and Z, which are the certification authorities for client and the server, they are being certified by this X. And hence the server, it sends the certificate, its certificate, which is issued by Z, and the certificate of Z, which is issued by X, will be transmitted to the client. So that a sequence of certificates will be, a chain of certificates will be transmitted by the server to the client to prove its authentication. To prove its authentication here. So to prove its identity, then followed by the server public key. Server key exchange will be done. So this will be done based on the key exchange algorithm that we have used previously. Based on that, you can have the key exchange protocol being running. And then the next step is the server can optionally request for the certificates of the client, where it wants to verify the client, so it can request the certificates of the client. So it can specify what are all the list of certificates that it can accept, and who are all the certification authorities who can sign your certificate that can be accepted by the server. So that certificate request can be sent from the server to the client, and then followed by the server hello done message. So this ends up like the server is authenticated and the key exchange from the server side is being done. So that will be done from the server to the client. So that is the second phase. So in the second phase, the server is authenticated to the client, and the client knows the public key of the server if it is required. Once the certificate is exchanged, then it comes to know regarding the server certificate if it is required. So these are the 4 cases, we have seen various key exchange algorithms, right? So the key exchange algorithms can be used at this particular phase where the server key is exchanged here. So this is the one. So when you are making use of RSA algorithm, so the RSA algorithm, as we have seen previously, this particular key value, the key will be generated by the client, and that will be encrypted with the public key of the server, right? So for that, what is required is the server has to exchange its certificate, send its RSA certificate to the client. And when you go for anonymous Diffie-Hellman key exchange algorithm, so these are the 2 Diffie-Hellman key parameters, global parameters that has to be exchanged, and this is the public key of the server that will be exchanged here. There you don't require any sort of certificate here because it is an anonymous Diffie-Hellman key exchange. If it is an ephemeral Diffie-Hellman key exchange algorithm, here you can make use of either RSA algorithm or it can be a DSA algorithm that can be used. For that, what is required is the client has to send its RSA certificate, signature certificate, or the DSS certificate being certified by a certification authority. A chain of certificates can be transmitted here, and then it signs that particular this values G, P, and G to the power of S with its private key, and then transmit it to the client. So this is how the server key exchange is done in the second phase, making use of ephemeral Diffie-Hellman key exchange algorithm. If they have fixed on, if they have negotiated on fixed Diffie-Hellman, then the fixed Diffie-Hellman certificate of this particular server has to be transmitted, where this value G, P, G, D to the power of S mod P will be certified by a certification authority. So that can be transmitted to the other end. So these are the four cases that other cases we are leaving, the Fortezai we are leaving, and the other one is none, where you need not have to exchange this key. So that is being left. So these are the, this is what is done in the phase 2 of handshake protocol. So when you go for the phase 3 of the handshake protocol, this is what you are going to have. The client authenticates itself by sending its certificates. So these certificates, when it is transmitting, it has to transmit the certificates that is requested by the server. If it does not have that set of certificates, then it has to send an alert to the server saying that no certificate exists from this particular certificates that you have requested. That should be transmitted by the client to the server. If it has that certificates, then it has to transmit certificates. Then it is followed by the client public key. So the client exchanger sends its public key. So that is the client key exchange algorithm runs here. Once that is done, then the client can send a request to the server to verify its certificate, where it generates a hash code in order to prove that that particular certificate belongs to this particular client. So that is the third phase of handshake protocol. So after the third phase, the client is authenticated to the server, and both the client and the server will be knowing the pre-master secret, because the client also will be exchanging its key, and hence based on the previous server key, making use of these two, they'll be exchanging the they'll be generating the pre-master key, as we have explained in the previous slides. So this is these are the four cases that we have in phase 3. So the first one, like if you are making use of an RSA algorithm, so in the previous case what we have received is the certificate from the client. So make a server, sorry, RSA certificate from the server. So making use of that particular public key, right? The client generates a pre-master secret key, and then it will be encrypted with the client's with the server's public key, and that will be transmitted to the server. So this is how we are going to establish the pre-master secret key, making use of RSA algorithm. And when you go for the other one, Diffie-Hellman key exchange algorithm, so previously the client has sent this value G, P, and G to the power of S. Now client will be sending G, P, and G to the power of C, where G to the power of C is its public certificate, public key, and C is its private key. So when they have exchange, when they exchange both, they both of them can generate the public key by raising this server generates this public key by raising this G to the power of C to the power of S. Thereby it gets G to the power of CS mod P, and server also generates this by raising this G to the power of S to its private key C. Like this, you are going to establish a pre-master secret key. And when you go for ephemeral Diffie-Hellman key exchange algorithm, so yeah, the client sends its RSA or the DSS certificate that is being used for signing this particular values. So that certificate is transmitted to the client and server, and then it sends this ephemeral value, this key values G, P, and G to the power of C signed with its private key to the server. So previously it has received this, and it will be decrypted, making use of, it will be decrypted making use of the RSA certificate public key of the server, and then it raises this G to the power of S to C. Like this, it will be establishing a pre-master key after the phase 3. And similarly, when you make use of fixed Diffie-Hellman key exchange algorithm, as we said, this values, this half key of the client will be certified by the certification authority. That certificate will be transmitted to the server, and then they'll be decrypting this, making use of the public key of the certification authority, and then they'll be generating the key similar to that of how you have generated, making use of this anonymous Diffie-Hellman key exchange algorithm. So this, after this phase 3, both the client and the server have authenticated each other, and they have established a pre-master secret key. So in the fourth phase, so you are going to run this chain cipher specification protocol, as we said, so that all these pending values which you have has to come into the active state. So for that, you are going to in the phase 4, where it is the finish phase, where the client sends a chain cipher specification value to the server, and then it sends a finished message to the server, where it generates a hash value making use of MD5, and then concatenates it with the hash value generated making use of #1 on the entire messages that are being exchanged in the handshake protocol between the client and the server. And then the server responds with a chain cipher specification value, and also it generates this MD5 and the hash values and concatenate it, and these values are generated over all the messages that are being exchanged while establishing this particular session. So all the handshake messages that are being exchanged, over that it is going to calculate this hash value, and that will be transmitted to the client. So like after completion of this particular phase 4, the client and the server are now ready to exchange the data, where they have established the keys are being established, and the algorithms are being decided, and further communication can be secured by making use of these keys, and that will be done at the record protocol. So when we look at SSL chain cipher specification protocol, as we said, it will be run at the end of the handshake protocol. So this is one of the SSL cipher specifications protocol which rise above SSL record protocol, and that makes use of the services of SSL record protocol. And the message that you are going to exchange here is a single message with a value of it is single byte that you are going to exchange in this particular chain cipher specifications protocol, and that message contains the value 1 in this. So wherein this, after running this chain cipher specification protocol only, the pending state will become active, will be moved to the active state or to the current state, thus updating the cipher suit that is to be used between the two communicating parties. So this is how the chain cipher specification protocol works. So this is the value. These are the values that are being negotiated. So the client has sent W at the client end. It says that these are the values that it has sent to the server, and these are in this particular table. It specifies these are the values that it has received from the other end. Similarly, the server also has sent these values, and these are the values that it has received from the client. Now this, after 3 phases where they have exchanged all this information, they'll be in the pending state. Once the client sends chain cipher specification value, this particular value, to the server, then what it does is, once it sends this, all these right values which it has negotiated with the server will be moved into the active state. That is, hereafter these values will be active. So that will be moved into the active state, and then the client sends the finished message, and at the server end, the server, once it receives this chain cipher specification protocol, then it moves these RAT values. So these are the values that it has received from the client. Now the client has sent the chain cipher specification protocol, and hence these values which it has received from the client will become active. So they'll be moved into the active state. And then the server, it sends a chain cipher specification value to the other end. Thereby, all these values, the right values that we have here, will be moved into the active state from the pending state. So now it becomes active. Once the client receives this chain cipher specification protocol, followed by the finished message from the client, from the server, then it moves all these read values from the pending state into the active state. So this is how the chain cipher specification protocol runs at the end wherein both the parties which has negotiated on these values will come into the active state. The other protocol that we have at the upper layer is the SSL alert protocol, wherein this whenever there is any exception that has happened, that will be intimated to its peer by making use of this SSL alert protocol. So it conveys the SSL related alerts that are being observed by a peer and by a node, by either a client or the server to its peer entity. So as we said that there are two types of alerts based on the severity, whether they can fall into warnings or they can be a fatal alert. As we said, if it is a fatal alert, that connection has to be destroyed and no more connections can be established over that particular session. So these under these fatal alerts, you have number of alerts like unexpected message, bad record MAC, decompression failure, handshake failure, illegal parameters, and all these comes under the fatal alerts. Once these fatal alerts occur, the session, the connection has to be destroyed, and the others fall into these warnings like close notify if there are no certificates. This is also one alert that has to be transmitted. If at all the server requests for the certificate of the client, if the client do not have that certificate which is requested by the server, then it sends this no certificate alert. Or whatever is required, whether the server has requested, if it does not find that particular certificate, then it can say that it is a bad certificate or it is a certificate that is not supported by it. All this can be transmitted to the other end, say other end in the form of a warning. So these warnings can be ignored, but if it is a fatal alert, an action has to be taken. And whatever data this data will be compressed and encrypted similar to that of the all SSL data SSL record protocol. So these are all the various alerts that are defined for SSL. So these are the values that are being given for this alerts. So when you look at the alert protocol fields that we have, it is a 2-byte data that you are going, 2-byte value that you are going to have. The first byte indicates what is the level of alert, whether it is a warning or it is a fatal alert. In that, if it is a warning, what is that particular alert? If it is fatal alert, what is that particular alert? So these are the various values that you are going to have for the various alerts that we have in that are being supported in SSL. So the part of this is SSL record protocol. Once the cipher suit is negotiated and the keys are being exchanged, then the processing has to be done for providing confidentiality and the integrity done by making use of this record protocol. So how the processing is done by the record protocol. So whatever data that you are going to get from the upper layer, that is either it may be from SSL alert protocol, or it can be SSL chain cipher specification protocol, or it can be from handshake protocol, or it can be the HTTP data that you are going to get. So whatever you get it, that data will be fragmented by the record protocol. So this is the first step that is involved in the record protocol processing, where it is going to fragment this data. The size of this fragment is to a maximum of 2 to the power of 14 bytes. So it divides all the data into 2 to the power of 14 bytes fragments, and then it can be compressed. So this is optional that we set. So the fragment can be compressed if the compression algorithm is exchanged between the client and the server. Making use of that compression algorithm, it is going to compress. If no compression is used, then it will be the fragment will directly be for that you are going to generate the MAC value, hash value here. So first, after fragmentation, compression will be done. To the compressed fragment, you are going to calculate the MAC, making use of write MAC secret. If it is from the client, it will be client write MAC secret. If it is from the server, it will be server write MAC secret that will be used. So making use of this, you are going to hash the compressed data. So this is what we call it as a message authentication code, and that is appended to this compressed fragment. And entire thing, the data along with the MAC is encrypted, making use of write cipher secret. And this encrypted fragment, to this you are going to add the record protocol header. So what does this record protocol header contains? So that contains the protocol, that is what is the version of this particular SSL. So what is the protocol, then what is the SSL protocol, or what is the protocol that you are going to make use of, and then what is the version. So in this 2 bytes, this is the compression type that you are going to have. So what type of data that you have got from the upper layer. So from the upper layer you can get it as SSL chain cipher specification data, or it can be alert data, or it can be handshake protocol data, or it can be HTTP data. So this protocol field specifies what is the data that is being carried in this particular packet, in this particular record protocol data. So that will be specified in the first 8 bits. The next 8 bits specifies what is the major version, and the next 8 bits specifies what is the minor version that is being used here. So this version field is of 16-bit. First 8-bit specifies the major version, and next 8-bit specifies the minor version here. And then followed by 16 bits which specifies the length of the compressed fragment. So what is the length of this compressed fragment? If it is not compressed, then what is the length of this particular fragment that you are going to specify in the length field. So here we saw. So the fragment is compressed. So this is the compressed fragment. To this you are going to add the MAC. So this entire compressed fragment and the MAC you are going to encrypt. So this is being encrypted. To that, this header is added. Record protocol header is added. So that is the output of the record protocol. So this record protocol is the one which offers confidentiality to the data that is being transmitted, and it offers authentication and integrity to the data by making use of this MAC function, hash MAC that you are going to make use of. So what is that we do in this hash function? So this is how the calculation of the MAC takes place here. So this is the MAC write secret. So if it is originated from the client, it will be client MAC write secret, and if it is the server, it will be server MAC write secret. When it is getting verified at the other end, it has to make use of the same value. That is, this server MAC write secret becomes the client MAC read secret. So which is same as that of the server MAC secret, that has to be used. So MAC write secret followed by a padding. So this padding, it depends based on whether you are making use of MD5 algorithm or SHA-1 algorithm. So this pad 1 is this particular value, that is hexadecimal value of 36 is being repeated. When you go for MD5 algorithm, it is repeated 48 times, and if it is SHA-1 algorithm that you are making use of, it will be repeated for 40 times. So that is this byte. So 48 bytes will be used when you go for MD5, with all the bytes will be having this particular value. And if it is SHA-1, it will be repeated for 40 times. Then followed by the sequence number for this particular message. Then followed by the compressed type. What is the type of compression algorithm that you are going to make use of? Followed by the length of the compressed fragment. So what is the length of this compressed fragment? Followed by the actual compressed fragment. Over this, you are going to calculate the MAC. So this is sent to a hash function. So this hash function will be negotiated at the time of establishing of the session, making use of handshake protocol. So that algorithm is used, and that generates the hash value. to this hash value, you are going to again hash it, making use of the MAC write secret and a pad2 value. So this pad2 value is this one. So this value 5C hexadecimal value is repeated for 48 times when you go for MD5 and 40 times when you go for SHA-1 algorithm. So that is used here pad2, and that is hashed again, making use of either MD5 or SHA-1, whichever is negotiated at the time of session establishment, and the output of that generates the MAC. So this is nothing but the HMAC function that we have used over here for generating the MAC. So this is how you calculate the MAC value over here, and that is appended to the compressed data, which can be encrypted by making use of the encryption. So these are the various algorithms that we have in the SSL protocol. So I'll be skipping all this message formats. So as we said, for science cipher specification protocol, the protocol data will be 20, which specifies that this protocol value, if it is 20, it specifies that this is a chain cipher specification protocol, and the length of this message is just 1 byte that we have set in the previous case. So this has a value of 1. So the length will be 1, and this message will be having a value of 1. That is in the chain cipher specification protocol. So in the alert protocol, this 21 in the protocol field indicates it is a alert message, and the length is, as we said, it is 2 bytes. So you are going to have this length as 2 bytes here. And then followed by what is the level of alert, whether it is a fatal or a warning, followed by the description of that alert, where you are going to specify those values that we have given, 0, 10 or something like this, which describes that particular alert that you are going to specify in the next byte. So this is the alert protocol. The other one is the handshake protocol. So this protocol version, protocol data, when you go for handshake protocol, is 22 in the record protocol header. Then it will be followed by the type of this handshake protocol. As we said, there are around 10 messages that you are going to exchange. So you are going to specify what type of message that you are going to specify here, followed by the length. So the message that varies based on the type of the size of the message varies based on the type of the message. So you are going to specify what is the length of this message. So in the generic header, you have a length which specifies this entire data may be compressed by the record protocol. That particular length you are going to have it here, and here you are going to have the length of this particular data pertaining to this particular handshake protocol type. So in this way you are going to have the handshake protocol data. So the types can be, as we said, there are 10 types of messages that can be exchanged. So these are the various types, and these are the various messages. Previously we have seen all these messages, right? So based on that, you have these different values, the length and the messages that you are going to exchange. It varies. So I'm just skipping all this. So just have it here. So as we said, in the third phase, when the client, during the client authentication, third phase of handshake protocol, the client can request for the server to verify the certificate. So when it requests the server to verify the certificate, it generates a hash value, making use of its hash value here for the server to verify. So this is how it generates the hash value. So making use of the master key, it generates this hash value and asks the other party to verify whether it is the same user, which is client, which is communicating to the server or not. So this is how you are going to generate this hash value, which can be verified by the other party. So this is the finished message. In the finished message, as we said, it generates the MD5 value and the hash value. So over the entire handshake messages, it is going to generate 1 it makes use of MD5 value and then it generates this value, and the other time it makes use of hash function and then it generates the hash value. So, and then the MAC value can be generated making use of the previous how you have generated that MAC value that you are going to generate, and that can be transmitted at the end of this finished message. So this is the application data. This is the protocol that protocol value here is 23, and then this is the upper layer data, that is from the HTTP. You have whatever data that you have got, you are going to compress it and then add the MAC to this. Either you go for a MD5 or SHA-1, which is negotiated at the time, and then you are going to encrypt it. So this is the application data. So there are certain differences that we have between SSL and TLS. TLS is the IETF standard version of SSL, and there are some more or less both are same, but there are slight differences. The differences is in the version. So the current version of SSL is 3.0, but whereas the current version of TLS after getting standardized is 1.0. So SSL 3.1 is nothing but TLS 1.0. And in the CipherSuite also, TLS does not support this particular algorithm FORTIS either for key exchange or for the encryption. And even when you are generating the MAC secrets also, key values, you are going to make use of different algorithm here, where you have a data expansion function like this, and then that data expansion functions are being used, making use of here you will be making use of when you are generating this MAC value, you can make use of MD5 algorithm, and the other one is SHA-1 algorithm. So this data expansion functions are used over here, and you are going to make use of a pseudo random function, which is derived from this key data expansion function, and that is used in generating the master secret, which is used with which will be generated with PM. So this pseudo random function is this, and this function is the data expansion functions. So there's a difference in the cryptographic computations that go on when you are generating the master key, and the same master key function can be used for generating the but here the labels will be different. So when you are generating the master key is the label, and when you are generating the key expansion, this is the master key, this is the label that you are going to make use of. So in this way, the difference will be there between the SSL and TLS. And in SSL and TLS, the notification, alerts are also, some of the alerts are being introduced, new alerts are being introduced in TLS when compared to that of the SSL. So in the handshake protocol, the certification verify, there we had two messages that are being generated, two hashes that are being generated, but whereas here you will be generating only one particular hash for certificate verify. So this is the finished message also. There is a change in the finished message. And in the record protocol, while you are calculating the MAC value, there is a change in how we are going to calculate the MAC value here. So this follows the same HMAC function when you go for TLS, but whereas the MAC function that you have used there in SSL is quite different from that of this. So this SSL, how are you going to implement this on your web browser? Most of the web browsers, they come inbuilt with this SSL. So HTTPS is what is the combination of HTTP and SSL are the TLS to secure this communication. And when we look at the URL, instead of HTTP, you will be having HTTPS. We all know HTTP makes use of the port number 80, but whereas HTTPS makes use of port number 443. So when you make use of this HTTPS, the data that will be encrypted includes URL, the document contents, the form data, cookies, and the HTTP headers. All this will be encrypted by making use of this HTTPS. So that's all. Thank you. Any queries?
Dear participants, you have any doubts, you can ask the madam.
So make it faster because I have a meeting.
Okay. Dear participants, if you have any doubts, you can ask directly to the madam. Okay, I think there's no doubts. So thank you, madam. Thank you once again.
Thank you, sir.
So thank you for the wonderful session. It was very informative. Thank you all the participants for attending this session. Participants, feedback link will be shared in the group. Okay, please fill the details of the feedback link. Thank you, madam. Thank you once again. Thank you.
Thank you, sir. Thank you.
Thank you very much.